Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hey, I'm John.
And, we don't have Ed with us today. So we are, he's out doing his,
He's here in spirit.
yeah, he's here in spirit. He's out having fun with the family. So,
Yeah.
we'll give him that. Um, so, last week, we kind of touched on a few things, and then this week we wanted to do a little bit more stuff on 3D scanning. However, Ed's not here, so we're going to wait again. So this week we kind of want to get in start we want to talk about reverse 3D printing and reverse engineering, or reverse
Right.
engineering as a whole, um, because when you think about it, and for me, I look at the automotive restoration side of the house because that's where you're going to see a lot of reverse engineering. You're talking car like 34 Fords and stuff like that. You're talking Model Ts, for the love of God.
Yeah.
That,
Yeah.
yes, they're made out of wood, so you can technically get their replacement parts from Home Depot. Um, but the thing is, if you think about taking, the 3D printing technology and building parts for these vehicles that don't exist anymore, or they do exist, but they're hard to find parts for. And you can start reverse engineering those parts. Yeah, I'm not talking about making frame parts unless you're actively making measurements and throwing them in a metal 3D printer.
Yeah.
That's plausible.
I mean, it's still possible, right? Yeah. Like, so you're talking. I mean, this is a good start here. I think for some people, they hear reverse engineering get thrown out. I think we like to focus on 3D printing on a lot of our topics, but throwing reverse engineering and 3D printing together, um, it's cool to think about it because it actually the 3D printing process or one of the sub processes to get a 3D print can exist in many different stages of that reverse engineering process. I mean, you think about the basic way. How would I explain this to a fifth grader, right? Reverse engineering, you have a part. That part needs a special molding or tooling or anything like that, and doesn't get made anymore. So you start from something that you have, you engineer the way to it, like how do I recreate this? And it's going to be a different material, almost 100%, because you don't have the same resources. It's not made the same methods
Hmm.
as it was before, but you still create a very hopefully dimensionally accurate and dimensionally equal to that original print as possible. So you start with something you have, and you analyze, you take scans, you take measurements. We talked about scanning very much a couple episodes ago. We'll talk about it again, but that could be used as a process to reverse engineer a part. So like if you have like Nick was saying, if you have anything that's like, hey, this fender doesn't, it's at a weird angle, it's got a weird cutout, this model doesn't get made anymore. You can scan that. Now, you may not be able to print it in one piece, but you can use that to dimensionally size out the piece that you need, the area you need, and make sure it matches. And to be honest, it's going to be much more work than you would just go to the store and buy OEM parts, right? But that's the problem is that those don't get sold anymore, and you need to
Hmm.
recreate this thing. But that's with 3D printing, being and car parts being kind of the forefront of it. For me, I think it makes a lot of sense to reverse engineer some of these things because just everyday wear and tear, right? Like if you want to show off your your 70 or your 69 Nova, and you have a certain type of lock mechanism on your door, and that piece pops or breaks, I'm not sure you're gonna spend like $5 to go get another one. It's gonna be much more expensive than that most likely. Or you could maybe print one, and in that case you could use it and make it much cheaper, right?
Yeah.
So yeah, it's a process. I think that I can't since we looked at scanning, I can't think about reverse engineering something without thinking about scanning. Scan the item and then work on it from there.
Which that makes
So,
sense.
yeah, so that kind of makes me raise the question of like So I know that you got a scanner recently.
Hmm.
We're not gonna get too deep into that because I think that there's a lot to explore
Oh yeah.
on that side of the house. Yeah. So we'll leave that for another time because that'll be a whole nother rabbit
Yeah.
hole. But scanning as like a means to uh, get a object from the physical world into the digital medium,
Hmm.
but what do you think you would use in that once you get into that digital medium? Like you have the scan saved. Does that does that scanner
Ooh.
save it as like a
It
an STL? What's the file type? Like how
it
does that work?
it looks like it exported as an XDF. And it will export as an STL
Okay.
also.
Okay.
I think that's mostly how it does it. It does it over the air. So it'll actually like literally airdrop it to your PC. Um,
There we go.
or it will do it via cable. Um, if you want to do USB cable. Now, when you start talking about like the fun part about how do where do you use these things at, as far as software goes, you start talking about, and especially exportation software. Um, like for example, SEMA Garage. SEMA Garage has two locations. They have one in Detroit, Michigan, and they have also one in California. Um, SEMA Garage has a program for SEMA members who are allowed to get um, the 3D scans from the OEMs that can or the 3D CAD information from the OEMs to support product development. Um, but the thing about that is they do their own scanning with a Faro arm. So they use a Faro arm to do all their own scanning and 3D scanning and stuff like that.
What do you mean? So when you say Pharaoh arm, is that just a type of robotic arm, or is
Ye-
that a
Yeah, it's a Faro arms are a I guess you'd say like a hard mounted robot arm that's hand
okay?
controlled. So the human uses it, so it makes sure everything's nice and steady.
Okay,
Um,
so there it
yeah,
probably has some type of like leveling or like
right. It's a lot
gyroscopic.
more. It's like it's like the top of the line when it comes down to being accurate. They use these
Okay.
things for measurement houses, and accuracy testing to make sure that point-to-point clouds match, and stuff like that. So they're used in QC a lot. Um, but they scan all these things and they take them and they save them as STLs, and they export them over
Mhm.
to CAD programs, which then you can import into like Fusion 360, SolidWorks, and all those other programs. That where you can go in there and modify them, do measurements, and all the other fun pizzazz.
Okay.
So that's always available. But you can always do something cool with them. You can always upload them to, well, not upload them, but if you were trying to look at them, like what we were talking about, we were talking a little bit about this before we started, is the AR side of the house, is upload them to oh, I can't remember the name of the software. It's the digitization software that they use to make like figures and stuff like that, 3D. Um,
Maya? No.
so-
Um, Fusion 360?
Something. It's one of the open source
I th
platforms.
I think a Blender.
Blender, yes. You can upload it into Blender and turn it into an AR type of application where you can like see it via a set of like HUC Vives or something like that, and actually see your part in 3D.
Mm.
Um, to give you an idea of kind of what's going on. Um, which is kind of funny because I just saw something. I don't know if anybody watches the YouTube channel Cletus McFarland. Um, Cletus McFarland is having a body made for one of his race cars, and they actually used augmented reality and reverse engineering based off of 3D scanning to actually do the aerodynamics testing and the body design.
So they were able to kind of simulate airflow or like streamlines and things like that across the body of
Yep,
the car.
yep.
That's pretty cool. I mean, I imagine. So for me, this is also very new, you know. So I mean, I had to ask you what you meant, but with the Faro arm and things like that, because the handheld scanners haven't really been a thing for very long, right?
Right.
And when I say very long, it's like in the overarching thing, maybe about a year or so. Good quality ones have been around, but been very expensive.
Yeah.
Maybe probably more recently it's getting a little bit cheaper to have these and be able to keep them, like I wouldn't say keep them in your garage, but you know
It's
you can
finally
keep them so you
consumer
can use in the
based.
garage. Yeah, exactly. Um, that's one of the things that like I'm curious about when we talk about reverse engineering a part or for something like that. Like personally, the process of getting a scanner and reverse engineering something is interesting to me. So like that means that I would probably use that in my garage if I'm like, oh hey, I see this. I see that I replaced my radio, so my dashboard is starting to break. The clips broke off or something like that. I can I can reverse engineer that piece and recreate or fix it back. So if I want to do anything, if I want to get rid of it, if I want to upgrade it or anything like that, I can have it look like new, if that makes sense,
Right.
right?
And if you and
So,
if go ahead.
yeah.
Sorry.
No, 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 you're fine. Go ahead.
If you think about it, like you could take these 3D scanners and you also do customization with them, reverse engineering again, and make and also 3D printing works right alongside it is you can make your like center consoles and dashes for or yeah center consoles for classic cars because and the reason I say this is because back in the day when they made these cars, the one thing they did not put in them is cup holders. So literally, we're having to use 3D printing and reverse engineering to add cup holders to vehicles that were never designed to have cup holders.
Yeah, it's really cool. Like I think about a lot how if I scan something I'd have to like so like let's say we get a scan of the inside of like maybe the center console, right? And how you would use that to recreate or to create a type of cup holder or whatever improvement you want to make to it. I think cup holders make sense and it's hilarious because we have a fascination with having a drink. I think that if you start looking around, everybody everywhere always has like something nearby them to like sip on or drink from. Um, we're kind of almost like we have to have that, but yeah, we didn't really have that in the cars before. The cup holders weren't there like that.
Yeah, and it's like I'm trying to if you think about it, like you're talking like you're talking about the no, like Novas and stuff like that.
Hmm.
If you order the the same decals that they made for these cars back, way back when, um, I hate to say way back when, it was in the 60s. Um, but they're kind of expensive. They're like 14, 15 bucks or something like that, I think. If you think about it, you have an STL of those, and you can convert that STL that you can take that STL and print it on a 3D printer, where your roll of ABS costs you $14, or
Yeah,
if you get it for a decent deal. If you're finding, okay, you might have to use PLA if you want that price.
yeah.
Um,
I mean, it depends on what the brand is that's making it.
right, Amazon is not, very friendly on pricing. But and you take that and you print them out and you hit them with. They now have like a chrome paint that if you add enough layers on after you sand it down stuff like that, looks great. You may be all in for material alone, maybe 20 bucks, 30 bucks, maybe 20 bucks. But yeah,
Hmm.
okay, so that costs more than the part that you're going to order online. However, now you can remake that part as many times as you need to get it right. And guess what? It's only going to cost you $14.
Yep. No, that's the thing, and like we talk reverse engineering, like and thinking about those like part of the essence and part of like what I would say in a personal opinion. I mean, you can agree, um, most likely, but it is we're not just going to. I mean, some people are purists and they want to make the exact same one for one piece. But in a lot of cases, for me, if I see that there's like something that I can kind of tinker and slightly upgrade or slightly change or tweak that's more friendly to me, fits me, makes it ergonomic, stuff like that. If it's something I'm like holding or a gimbal or something like that, then I'm gonna make that change, right? I'm
Yep.
gonna tinker with that. If I'm like, hey, I don't like how this sits in my hand. I want a more weighted grip or something like that. I'll leave a little bit of gap on the bottom and then probably maybe insert a different material underneath, right? So this that's just kind of the thought process when you're reverse engineering anything is not just one for one. With the classic cars, I understand. You want to keep it like you want to make it look as like pristine and mint as possible.
Well,
But
I agree with you.
yeah.
I'm a tinker, and I can't. I've learned I can't leave stuff well enough alone. Just because it's ingrained to try something. And the thing is, you can also use the those prints that you do for reverse engineering to put them through flow dynamics and testing and stuff like
Hmm.
that. Stuff that the older parts were never designed to go through. Some of those things, honestly, the aerodynamics of some of the old cars was like a lead balloon.
Yeah.
Um, it's a flying shoebox.
They're
Um,
thinking about power. They're not thinking about any of
right.
the consequences.
But now you have like now you're into the world of resto mod. Um, and so a lot of people, the theory of I have to have this correct. If it's not a numbers matching car, literally you're probably not going to get a whole lot of people making, period correct restorations if they don't have to. Unless that car is worth some serious cash, but
Yeah.
if it's like a GT 500, then yeah, the body's a GT 500. I'm going to go get a remake engine of that time and go from there. However, if it's just a run of the mill like 66 Mustang, for example, with a straight six in it. I mean, yank that damn thing out.
Hmm.
Not enough power, especially for this day and age. We're gonna get ran off the road by a moped. Um,
Yeah.
so it's like now with the resto mod coming to the forefront, the age of customization and reverse engineering when it comes down to like individualization, like making things individualized for cars, has made the 360. I think we're to that point now. um, People think it's, from back in the day, if everybody always seen Grease, you see the car with the spinning knives on the, on the thing, the flames and whatnot. Yeah, now we're
Yeah.
back into that again,
Yeah.
but
No,
with a little bit more
exactly.
technology.
Yeah, I think it's cool. You think make me think of Grease.
Why? I don't
uh,
know why that came to mind. I think I saw something
Grease Lightning,
about it
man.
on the other day, and it just kind of stuck.
Yeah. I mean, to be honest with you, yeah, it's like and the availability of 3D printing and scanning just puts that in everybody's garage. Like puts
Hmm.
that capability in everybody's garage. One thing I will say, I kind of did a little bit of brief research on kind because I don't have a scanner myself, so I'm just thinking about how it would work, and I don't have I have the printer, but the scanners kind of made been making me think about like reverse engineering and stuff like that, but also about we talk about tinkering or making little slight changes, but I think we should take time to talk about how. Like you talked about just importing it to Blender and tinkering with it, but I think that um, I think we should also talk about the use of like we use it as a stencil almost, right?
Yeah.
So you get the scan, you bring it into the software, you can not necessarily like if you have a part because I think I was watching a similar restoration. I don't know if it's the same YouTube video as you that you're referencing, but he didn't like he scanned the engine, but he didn't like how the scan came out, right? So that's something that we would probably in the most recent years have to deal with is a bad scanner or poor scanning quality of any type, so your file doesn't come out right. So that can probably happen to us today still, depending on how much you pay for the scanner, right? The
Hmm.
quality of that. Since LiDAR came out, it's a little bit easier to get the better quality scans, but that's regardless. Um, you still like if you have a piece that has like it's you're just sizing, right? You're reverse engineering and making sure this other piece fits, and you're just sizing this one piece. You don't need to necessarily not scan it. I think it makes sense to scan it because then you can remove all. You can only isolate the areas of contact, right?
Yep. Yep.
So in the example that I'm thinking of, he scanned a full engine and he was replacing the headers and he was making sure he sized the belts out right and had everything kind of aligned and that he wasn't putting like the drive shaft through the engine block
Hmm.
when he's building it, So it was a custom build by him, like you're talking about before, but he put the like he had a great like idea to put the engine up and all he did was engineer the header connections and then size the belt so that he didn't put something through his engine block. And it was just a safety, like just hey, I feel like if I just go after this without like having a picture, like that I can kind of reference, hence the the reverse engineering, you're coming back from it, right? Then it would be a little bit tougher for me to kind of push through the project, right? And I think that was a good example. It kind of like opened my eyes to the use of it, kind of going into software. He used Fusion 360, but I mean, I'm gonna be honest with you, I would probably use Blender, and I think I now need to learn a little bit more about it.
Hmm.
But you can use so much in Blender, and I think you talked about it before. I think RevoPoint probably has their own proprietary software. Um,
They're very
but
good.
yeah, well, listen, I mean, when you make a product, when you try to bring the price as low as you can to make a profit, then you end up skimping on a couple things. But if you want the quality to remain good, you kind of make sure that the product is good, maybe not the software.
Yeah, the
And
product's great, but
yeah,
it is what it is. But it's like, I think, I'm on the same boat you are, but I think that, you should when you start talking about reverse engineering, you really add in, 3D printing, or the additive manufacturing side of the house, because we know that not everybody is going to run a, FFF machine or FDM machine where they're going to run, whatever the heck they can find. Um, but
yeah,
you start, if you add a scanner to that, now you've got the whole package. Now you got, a little manufacturing facility in your garage, um, or multiple printers where you can, have, a little thing going on. It's like for me, whenever I redo my garage, and because I'm gonna get a project car, is I want to set up a section in the garage, in a corner where I have a enclosed 3D printer down there. I've got a mini PC down there. I've got a screen down there, and I've got the scanner down there just in case I need it. So I can go in there and find the stuff I need. Do the stuff I need to do there. Then I can start immediately send to the printer and say, "Cool, I'll get to it later."
yeah.
So it keeps everything right then and there. Yes, I have my fair share of printers, but I'm not going to go put an Ender 3 down in my garage just because of the fact it's not enclosed. Um,
Hmm.
and next thing you know, it's going to be printing something that looks like speckles.
Yeah, a lot of variables whenever you do that, because the print, I mean, depending on if your garage is, um, at least three walls are insulated, I can guarantee you that the door isn't like the most insulated. So
Right.
it's a bit tougher to maintain that unless you have that enclosure,
That might be one of the very few times I get one of the K1Cs or something like that from Creality.
like the models built into the enclosure, right?
Yeah,
That makes sense to me.
and that's just it's just one of those things because it helps build a little small little manufacturing facility for where you need it. And which kind of leads me to a point of all these companies, some of the newer companies getting into the reverse engineering and the modification side of the house, especially the customization. The fact that they're finally realizing that advanced additive manufacturing is here to stay and here to help. I think we've seen a boom in the use cases. I think we're
Hmm.
finally seeing that the climb in the use cases. We saw some at Rapid, when it came down to the reverse engineering side of the house. However, I think in the past year we've seen more and more vendors come out with 3D scanners. We've seen more and more vendors come out with new age software. We've seen
Yeah.
more and more new 3D printers come to market, um, that can do higher level filaments. I think people are finally getting to the situation where it's like, hey, guess what? This additive manufacturing stuff is here to stay, whether you like it or not.
Yeah, it's the manufacturing of the future. There's no way around it. I'm gonna be 100% honest with you. Like it's the cheapest. Like unless you are buying it from the source, and it's being made nearby, like all of these factors as far as a very specific specialized part, you're not really going to get as much value, if you're buying full parts, like unless you're buying the same part over and over, and it's nearby and made locally, like you're probably going to save money making most of your parts with a 3D printer, or using some type of scanning technology, or CAD. CAD software to get that model completed,
Mhm.
or get that model made, and fitted. Like
Right.
those things are, you're not going to get around that. So it's,
No.
I mean, for me, if you're 3D printing, I think in a lot of cases we're already like picking apart a lot of prints. Like when we see a cool print, we're like, oh, they probably did this. Like I don't know if you notice it, but it's every single time we look at a print, it's like, hey, this is probably the process he used, or that looks like it's this. So we're already trying to identify something, so that, like, honestly, if we were to continue looking at it, we could reverse engineer that thing.
Right. And it's like especially I keep going back to restorations because I think that's kind of where it's kind of fun at. And we've kind of talked about automotive restoration. Now, if we really want to get into something fun, you start getting, which I'm going to say this, if you're doing it, realize it's not approved yet. Is utilizing reverse engineering to support aeronautical restorations. So you start talking about, doing airplane restorations. Like if they're airplanes that are not flyable anymore, they're not FAA airworthy anymore.
Hmm.
And they're going to be museum pieces. Yes, please go right ahead and be my guest. If they are airworthy and they are flyable, please get that approved through the FAA before you go ahead and do anything. I do not want to condone anybody saying, "Hey, I'm going to 3D print that spring I need for my freaking landing gear," and you go splat when you go land. Nah, don't put that on us. So
Yeah,
disclaimer: if you are going to use additive manufacturing for any airworthy airplane, please get it approved by the FAA first. Um, Cars, you don't have to worry about that because no one cares.
drones
Um,
though don't, only qualify at a certain weight, and
right.
when you try to go over a certain height. So yeah, if you're trying to ride in that thing, get it cleared by the FAA.
Right. Or if you're doing any structural parts. But if you're doing like restoration for museum restorations, there's another fun one we were talking about. Reverse engineering is, museum restorations. Museum restorations for equipment, for um
Mm.
um for
Like,
airplanes, anything.
yeah, the bi-wings. Like I remember, I can't remember. I don't remember the airport, but there was an airport that had a World War II memorial, and it has like actual. Yeah, no, did we? Is that Chicago that we saw it in?
Yeah, I think so. Yeah, Midway.
Yeah, they had the actual World War II planes
Yep.
mounted above us. Now those things, like if you're just gonna hang them there just for show and kind of explain like this is the size so you can get an idea of it, stuff like that. Yeah, go by all means, go ahead and 3D print that. Nobody's gonna ride in that thing.
It's even the mechanical structural parts. Don't 3D print mechanical structural parts if you're gonna use them on a flyable airplane. Button switches and stuff like that. We have seen them where people have used from buttons and switches and been fine. But don't do it for like wing spires or anything like that.
Yeah, like to think about it, the like Crew 8, they're astronauts that just got sent to the space station a couple of days ago. Their helmets were 3D printed, if I'm not
Yep.
mistaken.
Their helmets and I believe their seats are now 3D printed, if I'm not mistaken.
Yeah. So, because they have to be fitted perfectly
Yep.
to them. So like that's one thing where it's like, okay, well I trust this to hold in a vacuum, but I wouldn't necessarily trust this to hold if I'm putting, a couple thousand pounds of torque behind it or any other force behind it, right?
Right.
Like if I'm depending on this to honestly, if I was depending on it to land an airplane, I would not go with anything 3D printed.
Right. It's something to keep you alive. And we've
Hmm.
seen a lot of stuff where, we have seen 3D printed helmets, and I think that's great. Anything to reduce weight, especially if you're talking about like combat helmets and stuff like that, 3D printing that way, doing reverse engineering for that to save the weight. Yeah, great. Um,
Yeah, I
and
wonder if they're better, like if they tested them against other helmets too
that maybe.
in a
Um,
vacuum. That'd be cool.
I know that, the one thing that I think the one guys who don't get enough love, um, when it comes down to like reverse engineering, especially not even from the 3D printing side of us, but reverse engineering as a whole, are the museum curators and the guys that are doing exhibits in museums and stuff like that.
Yeah, because they gotta figure out like how it worked. They gotta try to match it up, and then they've gotta try to print it to where it's like not noticeable for um, the structure. Yeah, I mean it makes sense to me. I think that it's funny. It'd be funny if most of your museums had 3D printers in them, and I would not be surprised.
No, that wouldn't surprise me one bit. And the thing is, it's like we talked about. I think we talked about during the scanning episode is, using 3D printing for doing museum-based curation. So you scan everything in, stuff like that. People can see them on HTC Vives. They can spin them around and augmented reality and stuff like that. You can also make it available to people who can't ever make it there. But using it to figure out, oh, this part broke here and this is what it would look like as a whole. So you have a spear that's broken in the middle. They don't know how it went together. Okay, cool. Here, let's put it all together via CAD and scanning and stuff like that, and print what it would actually look like above the part that's actually that was used during the time.
Right.
You know,
Usually, I mean, usually it's a lot tougher if you're gonna get any use out of something that's printed aeronautically. I think that the FAA has given clearance on some parts after quality assurance testing and stuff like that for some military planes to have a couple 3D printed parts, but not very many, not very many.
right?
So, but I think it's possible. I mean. Um, we have metal printers. Like, I think, to be honest with you, like relativity space and the way that they use the Kuka arms, I think that that's a way of reverse engineering. They knew what they had or they wanted to get,
Yeah,
and they just used a different method to get to the same product. Does that make sense?
yeah. And it's the funny thing is, this is gonna sound really, really funny, but I think that the FAA approved that launch, and I think they probably looked at it. The evaluator looked at it, and went, "Well, this will be fun.
There's nobody on board, right?
Well, that's good. Let's see how this goes."
Yeah, right. That I mean, it's like, hey, cross your fingers and get out of the exclusion zone.
Right. But
So,
they went up. It took off. Yeah, they had a couple oopsies, but they made it.
yeah.
Um, you
Are they
know,
gonna make Terran One now? They're gonna do
yeah, they're working on it slowly but surely.
um because they launched it
Or
the one time, but
sorry,
they're gonna keep
Terran R
Terran.
now.
That's what I yeah, that's what I meant. It's the larger version, isn't it?
Right. They went from like drinking a 20-ounce can, drinking a Coke can to going straight to the 2 liter.
Yeah. What are their goal? Did they say like plan is to get to the moon, plan is to get to Mars, or
Uh, that
just build a
per,
bigger rocket?
yeah, pretty much. Pretty much here.
Got
Let's
it.
build the biggest thing we can and just launch it.
Dude, they sound like Americans.
Yeah, yeah. I think
Make
they
it as
are
big
trying
as
to
we
go to
can.
Mars because one of their big things is they want to bring their manufacturing facility to Mars or to the moon or something like that because they're portable. Last time I checked, I don't know if a Tuke arm really flies well, but I guess that'd be interesting. You
You
know,
could probably pack it in a box, tight enough it doesn't really move that bad, right?
yeah. My
I
thing
mean, they got the
is
Parker Solar Probe like orbiting the damn sun.
yeah,
Excuse my
yeah.
French. Sorry, that's it's ridiculous. It's crazy.
But really makes me wonder is what does hydraulic fluid do in space?
Yeah, I
Like,
don't
and
know
like
if.
actually exposed to it. Like,
Yeah, they've got a lot. This is like the first time they've got a probe to orbit this many times around the sun and get this much um, data. So
mhm.
I don't know. Maybe it doesn't do well, but I'm gonna stay tuned to the Parker Solar Probe at least
Yeah,
to see what.
it's pretty cool. It's just we got stuff that made to the moon recently on a
Yeah, it's kind of
freaking
became
on
a
a rocket, right?
space podcast.
But the thing is, yeah. But the thing is, they ran out of battery. Um,
Yeah.
so and they're reverse engineering things because no one's been there in 50 years, or at least landed.
Yeah, so they have an example. Yeah, I mean, like, yeah, I don't know. You've heard the flight log when, um, was it Neil Armstrong had to take control of the lander?
Yep.
That's yeah, absolutely crazy. He had to, we're trying to use we're trying to use AI and lasers, um, which is crazy. We're using lasers everywhere now. And I think there's lidar as well on that ship or on that lander,
There was, but
so
it
it
wasn't
can.
turned on.
Yeah, I mean that's probably why it didn't land on its feet. But yeah, but it's supposedly they're trying to use the lidar and the scanning and AI all combined to get that lander to land so that they don't have to they can make it more automated, you know?
Right. And it's kind of funny that all the stuff that's reverse engineered these days to get to the point of where we're at. Even things being reverse engineered that we don't want reverse engineered, are making their rearing their ugly heads.
Hmm.
Um, you know, but the thing is if you think about it, how many people are using them for the better good? A lot. How many people are using them for the better worst? A lot. So it's kind of one of those things.
Yeah, it's hard. You don't get the good without the bad in most cases, but
Right.
um, like when you're reverse engineering something, if they're doing it for capitalism or just to make a quick buck, you're doing fast fashion or something like that. You're getting somebody else's stuff and kind of recreating it so that it's now quote unquote yours, or you can patent that different style that's only slightly different. Um, although it's like kind of slimy, it's almost like it's just tinier iterations of improvement, right?
Hmm.
And it's crazy because you can see in the fashion world it's how it looks, not how it works, right?
Right.
But you can see if something works really well, you can see the wave of companies adopting it
Yeah.
like lidar, for instance, compared to where it was like 5, 6 years ago. Some companies started using it. They realized how fantastic it is and how well it does in low light situations. And they feel like they need to incorporate it in their devices, right?
Right. And it's like I heard one thing the other day, and it actually reminds me of the reverse engineering side of the house. It says you engineered something so well when it ends up on Alibaba.
Ha! Yeah, they had to buy one of your products. Like, how do you think the Macintosh got made? They had to buy one of your products, and they had to take it apart, see how it works, see how it ticks. Man, Ed would have loved this episode. See how it ticks, see what it does, and then they had to recreate it and make it in, whatever form that they can.
Right. So you're successful when your stuff ends up on Alibaba or AliExpress.
I
Um,
think it's Timu now.
yeah, yeah, well, yeah, Temu is the other one. So it's either one of the three. What was the one before Timo or Temu or
Wish.
yeah, Wish.com.
Yeah, I think I'm still waiting for. I think I bought some curtains on Wish. It was like, we'll see you in 3 years. I was like, what? What?
We had to find somebody's idea to steal first.
Jeez. It's tough. It's tough. I mean, with everything being connected and everything's an app nowadays, it's like it's easy to spin up a business and do a kind of a copycat, right?
Right. But and I think that seeing the advent of reverse engineering to support things, I think is kind of where we're seeing it. Like the guys who are 3D printing like braces for arms that fit directly to somebody's arm or something like that. Just by scanning it, reverse engineering how that thing's set up, throwing a C channel in, a couple
Yeah, I think the new
zip.
casts that have been coming up are like fantastic ideas of like you see what we've been doing traditionally. You kind of engineer your own way to like fit it, and then like
Right.
you're saying, it's perfect.
And then of course you got the guys who are doing it for auto parts and stuff like that, but they're not really doing it to to change anything. And yes, they are making a profit if they're using it for restorations where they're charging money for it, but it's only because that part doesn't exist, and because most people are going to go buy OEM if they get a choice.
Yeah, it takes a lot of effort too, and it's not definitely not cheap, especially if you have to go outsource and if that person who you're outsourcing to has to get all the stuff. There's a lot of work that goes into recreating something from scratch.
Right. That's when you play the, what type of material am I doing this out of, and stuff like that, which kind of leads me down that little rabbit hole. Um, is when we're talking about uh, reverse engineering, just as a whole, um, and we throw in the material side of the house. What are you thinking as far as material goes for reverse engineering?
Well, I mean, honestly, in my opinion, it depends on the project, right?
Hmm.
If we're talking for cars, if you're just fitting something and you're trying to reverse engineer so that you can send a model to like some larger entity that could print or metal print out your part, I think that you could PLA is fine, right? PLA is not gonna, it's gonna fit. You're gonna be able to confirm. Then you're gonna have an example or a souvenir of your
Yeah.
print, but then you just send it off, right? However, if you're actually gonna be doing the making and creating the thing, then I think you're gonna have to think about how much you're gonna have to do a lot more investigation on how much force, how much torque gets put on something, how much force gets put on something, the stress factors for the print. If it's a mechanical print and you're gonna make it out of metal and stuff like that, I mean that's tough to do. But you can do fusion, powder bed fusion if you have like one of the smaller tabletops. But other than that, I'm thinking like your carbon fibers, your nylons, stuff like that. If you have something that's like maybe it's a handle, right? Not necessarily like has to be functional in the engine or something like that.
Hmm.
Yeah, nylon ABS wouldn't even be bad because you can use some um, um, acetone to vapor smooth the edges, or you could sand it down if
Hmm.
you'd like to avoid deformation. So yeah, it really depends. So for me, I mean most likely ABS or um, what is it? ABS or AB
ASA.
ASA, that's what it is. ASA is probably going to be better because it's a higher temperature threshold. So like if you're putting it in the engine bay or near the engine bay, I mean I would say ABS or ASA is still good enough,
Hmm.
right? Pet G is probably going to get a little melty, a little squishy in there, so over
A
time
little
it
sticky.
probably be bad. Yeah. So and PLA definitely would not be there whenever you went and looked for it again. It'd be melted away.
True.
So yeah, I don't know. I think that makes sense for me. What do you think? What would you? I mean, it's harder to do the metals and stuff like that, but not impossible. It's just more expensive.
Yeah, and
Um,
like they sell a kit you can get you can get and build your own at the house, for power bed fusion, type of, system, but it's like 5 grand for the kit. That's not including your powders and all the other, fun pizzazz. I'm like you. I lean more towards your ABS, your ASA, and stuff like that. Just because of the heat resistance and stuff like that, and the fact that yes, you can smooth it out, you can paint it, and it goes away.
yeah.
So, but the one thing that, kind of sets a, kind of a different precedence is the use of resin printers and the advent of stuff that's crystal clear. You start talking, lenses for cars, or
Oh yeah.
stuff that requires a clear piece to go over, as far as if you're building like a model or something like that that's like little mini windshields or whatnot. Or if you're printing a little glass piece, for if you're reproducing a gauge, like a steam gauge for an airplane, like a World War II
Yeah.
fighter, all the way through the Cessna 152s and 72s, all had steam gauges. If you're reproducing a steam gauge, you can actually have the clear, um, uh, the crystal clear, screen cover.
Yeah.
But
Right.
and you can do that with a resin printer, with a clear resin printer, from a couple companies. Um,
Yeah.
because
It's
and
pretty
then
cool,
just
and I
sand it
think
down and done.
yeah, I think that I'm gonna be honest with you. Resin printing is just so much better for detail. If you also incorporate the ability to have a better material, like a more, like there was some resin from Impact or not Impact,
Frozen.
Fosen. That's right. they could withstand impacts, and they could withstand like some of those stressors. It was able to kind of take that energy and dissipate it much easier than, let's say, your standard ones. We also saw prints from polyspectra that were just more durable, and they could hold more weight and things like that. So I mean, it's just about the polymer that you're printing. And I think it's what was they had like, it was like core or something like that.
Yeah, the core blue, core green, the core series of resins.
Yeah, I distinctly remember like trying to like you had one of those gauges judging how much pressure it takes or how much weight a clip can hold, and
Yeah,
it got up to like 300 pounds. I'm pretty sure for one of them, which is outstanding for something that's less than like 10 grams. Like it
yeah.
weighs nothing.
They didn't put it in they did put it in boiling water and try to turn it into goo, and that didn't work.
Yeah, no, it just kept. They would put it in the kettle. It's crazy. It's so to me, I think I agree with you. There are Um, no doubt chemists that are taking, let's say, they're like, okay, going out into the world. Now, this is great for reverse engineering. I mean, this is how a lot of science is done. Is like, um, you go out into the world and you find a material, and they're like, how, like for instance, lava, and you have rocks next to lava or anything like that. You're like, how you maybe find plant life. How has this plant life been able to live for this long, right? Maybe it uses the heat, or it expects the heat, so it's developed calluses on this, blah 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 blah. Whatever the adaptation ends up becoming, they use maybe that as a material or a resource,
Hmm.
and reverse engineer off of that to make, let's say, a better print or a better product overall. So, like for me, the chemists going into making these resins from these companies, they've got to look at so many different things. Like, how does a print do with thermal lighting? How does it do with infrared? How does it do with ultraviolet rays? Most of them are going to cure with ultraviolet. Um, but at the end of the day, all those other things still are going to be, interacting with that print or that model at some point, right? So how would they behave? You have to think about so many external factors.
Yep.
That it's also a good example of reverse engineering.
It's like, is it water cleanable or not? That's kind of
Exactly.
where you start dealing with that type of stuff. Those guys are doing some big things, and I think that it's only going to go up from here. Um,
Yeah.
I think we're heading in the right direction. I really do. Um, but I think we'll leave it at that. I think we're getting kind of long.
We keep kind of stopping ourselves from going too deep into 3D scanning. I mean, but it's
Yeah,
come up still a lot already.
and we try. It's like we try to hit all the high points and stuff like that. And because the thing is we could talk about this for hours, and
Yeah.
we don't want to make a podcast that or an episode that somebody has to turn off at midnight and turn back on at 8 a.m. so they could finish it the next day by midnight.
Yeah.
It's one of those things. Um, so with that, I want to say thank you to everybody who's tuned in, who's listened to us, who kind of gets the point of what we're talking about and who wants to be involved. The guys who are getting in there involved in STEM now, and people who are kind of paying attention and getting behind it. We thank you for that. I just looked at the all-time downloads. We're at 2258. There for a while we were hoping to hit 2000. At there for a while we were hoping to hit four.
Yeah,
Um,
I remember when it was just 4 digits. We were excited to hit.
but it's like we're getting there and we're having fun with it. And we hope everybody else is. Go take a look at some of the stuff we got going on. A lot of stuff is be linked down below, inside this stuff. Head over to if you're listening to this on YouTube or something like that, just subscribe for your next episode. We'll definitely get it to you. I see more and more people catching there. So, we appreciate you. We thank you. And I'll turn it over to Champ and y'all have a good one.
Hey guys, so I mean, I always echo what Ed says, or not Ed, Nick says, and Ed also feels the same. So it's kind of straightforward in how much we're appreciative for just even the platform and talking about some of the topics that are interesting to us. You can hear kind of this episode almost started to become a rockets and space episode,
We'll
and
do
a
more
lot
on
of them,
that.
yeah, a lot of them usually get to talk about that a little bit. But there's just so many fascinating uses and applied science to the space like race, the space aeronautics and everything like that. We just very interested in some of those things, and that's kind of why it goes in that route. So, honestly, for me, I would say I'd challenge you guys to um, take a peek at some of the upcoming events, like if it's a spacewalk or something like that, if it's the launch of a satellite, just take a peek at it and just take a second and think about how much work it took to even get to a successful launch. If someone's in space, how much work it took to get them to even be in space and know what they're doing at that point. It is a outstanding amount of work. It's crazy. It's phenomenal. But all of the innovation that they're doing is pushing the innovation here. So take a peek at some of those things. It's pretty cool. Next space flight, but also look at vulcanar.com and some of those things we got. We're probably gonna do a review on that scanner you got, Nick. At some
Oh
point,
yeah.
we need to get kind of elbow deep and start playing around with it to see what we can do with it as far as um, what's the size of scanning and stuff like that. I'm pretty interested in that. So you guys stay tuned, and yeah, we'll got some interesting stuff coming.
All right, y'all. Have a good one.
Take care.
All right.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.